In this problem, we're going to look at a projectile at an angle problem. So we have a soccer player that kicks a ball from the ground level with an initial velocity of 22 meters per second at an angle of 40 degrees above the horizontal. Neglect air resistance and assume the ground is level. And we want to find the x component of the initial velocity. So the first thing we're going to do is to draw a quick sketch. Here is my ground level. Here is my soccer ball. It's kicked at an angle 40 degrees. The velocity is 22 meters per second. I want to next indicate my positive direction. I will indicate right as positive, and this is arbitrary, but you do need to set your positive direction. I'm going to set up as positive. The next step I'm going to do is to set up a chart. The first column will be my variables, delta x, vi, vf, a, and t. And this will just help me to organize the problem. The next column will be for the horizontal motion, and the last column will be for the vertical motion. Okay, so I'm going to go ahead and just start filling this out. Whatever I know, I'm going to fill it out. So first I know horizontally that for projectile motion, there is no acceleration. So we'll put a 0 here. I know vertically, it's going to accelerate 9.8 meters per second downward. I'm going to put a negative because I made up positive. So this is negative 9.8 meters per second squared. Now horizontally, the initial velocity is going to be a component of the 22 meters per second. So I'll be using a little bit of trig here. If I consider this triangle right here, I can see that cosine 40 degrees is equal to the opposite, or cosine is going to be equal to the adjacent over the hypotenuse. This adjacent here, I'll go ahead and call that Vx, okay, for the horizontal velocity, over the hypotenuse, which is going to be 22. And so my velocity at any point in time is going to be Vx is equal to 22 cosine 40. Okay, and that's going to be constant. For the vertical motion, I can use sine 40 degrees, and that will equal the opposite, which will be my Vi, my initial in the vertical. I can call that VIY, so I know it's the vertical, divided by the hypotenuse, which is 22. Okay, so the initial velocity in the vertical direction will be 22 sine 40 degrees. Okay, so that's what I've been given. All right, so from here I can answer the first question, which is what is the x component of the initial velocity? So the x component of the initial velocity is just this, 22 cosine 40. So Vx is equal to 22 cosine 40 degrees. And make sure you are in degree mode. If you calculate that, you get 16.85 meters per second. Go ahead and box that. Okay. Number 2, what is the y component of the initial velocity? The y component, that's going to be this number here, 22 sine 40. So the y component of the initial velocity is 22 sine 40 degrees, which is going to be 14.14 meters per second. Okay. The third question is how long does it take to reach the peak trajectory? So I'm going to use one of our kinematic equations, and I'm going to use Vf equals Vi plus At, because I have 3 of the variables and I'm looking for t. Now we're looking for the peak, reach the peak trajectory. So at the peak, say this ball goes all the way up and then comes back down. So the peak is going to be up here. This is the peak right here. Okay. At that point, vertically, the velocity is 0. Okay. So vertically, the velocity is 0. So I am looking at when it's launched up to the peak, not when it comes back down, but just at the peak, at the highest point. The initial velocity I've calculated in the vertical direction is 14.14, and the acceleration is negative 9.8, and I'm solving for the time. If I calculate the time, I get 1.44 seconds, and that's the time to reach the peak. Now, the next question is, what is the total time? So the total time will be taking this number times 2. So I'm going to take that number, because that's to reach the peak, and then that's going to be halfway on its trip, and then now it's coming back down. So the total time is going to be 2 times 1.44 seconds, which is 2.88 seconds. Okay. Now the next question is, what is the horizontal distance the ball travels? So that's going to be number 5, horizontal distance. So to find the horizontal distance, we know that horizontally it's moving at constant speed. So that's just going to be delta x equals vt, or constant velocity, I should say. And so the displacement is equal to the velocity times time. And we can use this if it's moving at constant velocity. We know that the horizontal velocity is 16.85. We calculated that in part 1. And the time here, the total trip time, is 2.88 seconds. And we get 48.5 meters. Okay. And then lastly, we're looking for what is the peak height. What's the peak height the ball reaches? What's the highest point that the ball reaches? And for this one, we're going to use another kinematic equation. Delta y equals vi. Now, I know it's vit, but I'm going to put viy because we're talking about the vertical direction. Viyt plus 1 over 2 at squared. All right, so I'm going to plug in my numbers here. So I know my initial velocity in the y direction right here is 14.14 times t, which is 1.44. Why am I using 1.44 and not 2.88? Because this is the whole trip. This is the trip all the way to the highest point. That's why I'm using 1.44. Plus 1 over 2 times negative 9.8. And then the time here is 1.44 again. And make sure you square that. Square that first before you multiply it by the negative 9.8. And then we get 10.2 meters. So in this first problem, we see that the ball comes back down to the same level, the same height, back to the ground. Now let's take a look at a problem where it doesn't land back on the same level. So here we have a soccer ball. We kick the soccer ball from the top of a building at an angle of 30 degrees above the horizontal. The ball is launched with an initial velocity of 20 meters per second. The total time of the flight from the launch until it hits the ground is 5 seconds. And we want to find the height of the building from which the ball was kicked. So we're going to start with a drawing. And here's my ball. Kick it at an angle of 30 degrees. And it's going at a velocity of 20 meters per second. We want to indicate the positive direction. I'm going to make right positive in the x direction and then up positive for the y direction. And next step is to create our chart. So the first column has the variables, delta x, vi, vf, a, and t. The next column is for horizontal motion, last column for the vertical motion. Okay, so now we can start filling things in here. Okay, I know that cosine 30 equals adjacent over the hypotenuse. Okay, so you can see this, there's a triangle right there, right? So that's going to be my Vx divided by 20, my hypotenuse. And then sine 30 is equal to my opposite. It's going to be Vi in the vertical direction. So Viy divided by 20, my hypotenuse. Okay, so I can start filling this part in here. So this first part right here will be 20 cosine 30 degrees. Okay, and then my initial velocity in vertical is going to be 20 sine 30 degrees. Okay, Now I know the acceleration horizontally is going to be 0 because there's no acceleration in the horizontal direction. Vertically, it's going to be 9.8. And because I made a positive, this will be a negative number. Okay. They also told us that it takes 5 seconds for it to hit the ground. So 5 seconds and 5 seconds here. All right. So now I want to find the, I want to first find the components I want to find the horizontal and vertical component of the velocity. I know it didn't ask for that, but I'm just going to do that because I might use some of those numbers, and it's kind of good practice. So I'm going to take Vx is equal to 20 cosine 30 degrees, and that is equal to 17.2. Make sure you are in degree mode on your computer, on your calculator, and then Viy is going to be 20 sine 30 degrees, which is 10 meters per second. Okay, so now we're looking for the delta y. We're going to use one of our kinematic equations, delta y. We're looking for how tall is the building, right? How tall is the building? And so delta y is equal to Vi, and then y, because we're dealing with vertical direction, Viyt plus 1 over 2 at squared. Okay, so the Viy is going to be 10. We just calculated that, so I'm just going to bracket that because we're going to use that. So that's going to be 10. T is 5 plus 1 over 2. A is negative 9.8 times t again. Once again, we want to square this 5 before we multiply the negative 9.8. Okay? If we do that, we get a number. We get a negative 72.5. Now, why is it negative? The reason it's negative is because we're talking about a change in position, a displacement. And we started from the top of the building, and then now we went down. And you'll notice in the beginning I made a positive, and so it makes sense that our displacement is going to be negative because we're moving in the negative direction. Okay. And then the next question is the horizontal distance the ball traveled. What's the horizontal distance? Now horizontally, we know it's moving at constant velocity. So delta x equals Vxt, and Vx, we calculated that here. Okay, this is one of the components of the velocity, horizontal component, 17.32 times t is 5 seconds times 5, and we get 86.6 meters.